we're going to jump into some of the calculations. So we will start off with the basics, and then as we go on, it's going to get slightly more complicated. So first example, calculate the pH of this concentration of hydrochloric acid. So you can see it's not as concentrated, it's quite diluted. I mean, if you're talking about 2 molar or 3 molar, and even higher than that, that's when we start going into concentrated acids. So the first thing you always do is you always write down the balanced reaction equation of the ionization. So you can write down, if you dissolve it in water, what will happen? You will form hydronium ions and you will form chloride ions. So now we need to look at our reaction equation. Is this reaction balanced? So let's count the number of hydrogens here. We have 1 plus 2 is 3. On this side we also have 3. Then we have 1 chloride here, we've got 1 chloride there, we've got 1 oxygen here and 1 oxygen there. So this is definitely balanced. Now you need to also then write down your molar ratios. So in other words, the ratio of this to that is 1 to 1 and 1 and 1. There's no other numbers in front of these molecules, which mean that they react in a ratio, a molar ratio of 1 to 1 with one another. So my concentration of hydrochloric acid is 0.02 moles per cubed decimeter. So I want to know what is the concentration of this. That is what I'm interested in, because at the end of the day, when we do our pH calculation, remember that the pH is the negative logarithm of the hydronium ion concentration. So we are interested in knowing what is the concentration of my hydronium ions. Okay, so for now, this is given. And you know from stoichiometry or molar ratios that it is reacting in a ratio of 1 to 1 with one another. So in other words, if this is the concentration of hydrochloric acid, then this will be also the concentration of your hydronium ions in solution. So now that you have this concentration, you can now go and do your calculation. So the pH is equal to the negative logarithm of the hydronium ion concentration. So you know that concentration is 0.02. I'm not going to put in the units now. And if you work out your pH, you will get a value of 1.70. Okay, it was 1.698, but I just rounded it off to 1.70. Okay, so that was the pH for the first one. If you had to go and write down a Ka expression for this particular reaction, Ka, so then you would add your products, which is the chloride ions and the hydronium ions, over the reactants, which is aqua or in gas phase, and that's the hydrochloric acid, and that will be your dissociation or ionization constant of your acid, the expression. Okay, moving on to the next example now. They're actually giving you the mass. So they tell you that you have 8 grams of magnesium hydroxide and they're giving you the volume. So always record what you have. So you have the mass and you have the volume. Now remember that this volume is recorded in milliliters, okay, or in cubed centimeters. So we're going to have to convert this to cubed decimeters in order for us to do our calculation. So you're going to say 500 divided by 1,000, and that's going to give you the volume in cubed decimeters. Okay, now where do we start? First of all, what is the formula of magnesium hydroxide? Okay, that's a good place to start, because if you don't know how to write down a formula, you won't be able to write down the reaction equation. So on your periodic table, magnesium is in group 2, so that means it has 2 valence electrons and therefore a charge of +2. Then you know hydroxide is OH minus. So when we combine the formula, remember that those charges go to the bottom, and when we combine the formula, it becomes magnesium hydroxide, and that 2 goes on the outside, and that 1 went to go sit there. Okay, for example B, I'm just going to rewrite this on a separate piece of paper because the calculation is quite long and I don't have enough space on my previous slide, so I'm just going to rewrite my balanced reaction equation. So we said that magnesium hydroxide dissolves in water, and I'm just going to illustrate the dissolving in water on top of the line, because I don't want this water to be part of my balanced reaction equation, because remember, this is just illustrating the ionization of the salt. Remember, this is a salt, it's solid. Why? Because you have weighed out 8 grams of your salt, and then you will have your hydroxide ions. Okay, so what we need to do now that we have our balanced reaction equation, is we need to check what are we working with. What do we have and what do we want to calculate? So if I can quickly just rewrite the formula to work out pH. pH is the negative logarithm of the hydronium ion concentration. So we need to calculate the hydronium ion concentration, but in our reaction equation we don't have that, so we're going to work with the hydroxide ion concentration. And from getting this concentration, so we want to know what is the concentration of the hydroxide ions, because if you know that, then you can calculate the hydronium ion concentration by using the ionization constant of water. So because the ionization constant of water is equal to the hydronium ion times the hydroxide ion concentration. Okay, so if you can get this concentration here, then we can work out the hydronium ion concentration. So that's the purpose of what we want to do now, is we want to calculate this concentration. So to do so, we are going to start by what we have. First of all, we have the mass, we have the volume. So if you have mass and volume, you can calculate concentration. Okay, formula for concentration equals the moles divided by the volume. Okay, so we need to calculate the moles first, and to calculate the moles, you have to take the mass divided by the molar mass. Okay, which is basically your atomic mass that you can get on the periodic table. So let's start off by calculating our moles first. So we know that we have 8 grams. And to calculate the molar mass, you're going to have to grab your periodic table and read the atomic mass from your periodic table. So for magnesium, it has a molecular mass of 24.3. Oxygen is 16. So it depends on your periodic table. Sometimes you will have 2 decimal places, or sometimes you will have 1, or nothing at all. And plus, remember this is times 2, okay, because there's 2 oxygens and 2 hydrogens. And 2 hydrogens, so it's 2 times the molar mass of hydrogen is 1.01, or you can just, I'm just going to use 1 for the purposes of this calculation. Okay, so if you work out the moles, then you will calculate 0.1372 moles. Great. Okay, so now that you have your moles of your magnesium hydroxide, you can now go and do a molar ratio sum where you work out the moles of the hydroxide ions. If you can work out the moles of the hydroxide, the concentration of your hydroxide. So the first thing before you start calculating your moles is to make sure that your reaction equation is balanced. So if we look at my magnesium atoms, I have 1 on this side of the equation and I have 1 on this side of the equation. So my magnesiums are balanced. If you look at the amount of oxygens, remember that this 2 gets multiplied in. So you can see that I've got 2 oxygens on this side and 2 hydrogens on this side. But on this side here, I only have 1 of each. So I'm going to put a 2 over there to ensure that my reaction equation is balanced. So now if I write down my molar ratios, remember that you always write down this molar or the ratio number in front of the molecules. So you can see that that is 1 to 1 to 2. And this will be very important because we are going to use this molar ratio to then calculate the moles of your hydroxide ions. So you first of all write down what you are comparing. Then we know that this is 1372 moles. So if you want to calculate x, the unknown, remember that you multiply when you go across and you divide when you go sideways. So to get x, you're going to times this concentration by 2. Okay, so the concentration of your hydroxide ions will then be 2 times 0.372 moles. Okay, and if you work that out, that's going to give you 0.54. Let me just double check if that's the answer. 2 times 0.1372 gives me, that gives us 0.2744 moles. Okay, so now we have the moles of the hydroxide ions, but we don't want that, we want the concentration, right? So to get the concentration of my hydroxide ions, I am going to take the moles divided by the volume. So I do have the moles. I'm going to divide it by the volume. Now remember that 500 milliliters has to be in decimeters because 1 milliliter is equal to 1 cube centimeters. So to get that into cube decimeters, I need to divide by 1,000 to get it in cube decimeters. And here you can also see the units of concentration, moles over cube decimeters. So if I work that out, I get an answer of 0.5488 mole per cubed decimeter. So that's now my concentration of my hydroxide. So I have this, and now you can go and calculate the concentration of your hydronium ions. So let's quickly work that out. That should be 14, by the way. And let's see, hydronium, this is what you want to get. And the concentration of hydroxide is what we have just calculated. Okay, so to get the hydronium ion concentration, you will have to divide this divided by that, right? So let me just put that into my calculator. To the negative 14 divided by 0.5488, and that gives me a concentration of 1.82 times 10 to the negative 14 moles per cubed decimeter. Okay, and now you just want to work out your pH. So the pH is the negative log of this concentration that you have now calculated. Okay, and if I put that into my calculator, let's see, negative log of the hydronium ion concentration, and I get a pH of 13.74, and that should make complete sense that your pH is so extremely high because magnesium hydroxide is a base. So, and in solution it gives you a high concentration of hydroxide ions, and you can even see how small the hydronium ion concentration is, and therefore your pH will be very high. Okay, so let's move on to the next example. Okay, for question C, you're going to work with the same principles. So first thing that you always have to do is write a balanced reaction equation. So sulfuric acid will ionize into sulfate ions and into hydronium ions. Okay, and you can now go and balance this. If you struggle to balance this reaction equation based on the hydronium, you can always, instead of writing that, you can always just write hydrogen ions. Okay, the reason why we use hydronium is, remember, because we have water in there as well. Okay, so the hydronium ions or hydrogen ions, if we look at the balanced reaction equation, you can see that in this side of your reactant side you have 2 hydrogen atoms, but on this side here you only have 1. So I'm going to have to put a 2 there to ensure that it's balanced. Here I only have 1 sulfate ion, and here I only have 1 sulfate ion. So that makes a lot of sense. Remember, this is a diprotic acid, so it's going to donate 2 protons. So now if we look at the molar ratios, this is 1 to 1 to 2. Okay, and that's going to become very important later on. So they give you the concentration of your acid here. So that's 2.5 times 10 to the negative 3 moles per cube decimeters. So if you compare that concentration to your hydrogen ions, it's 1 to 2. So to get this concentration, you will take that and times it by 2. And you will then get a concentration of 5 times 10 to the negative 3 moles per cubed decimeter. So now you have your hydronium ion concentration. So now you can just go and do your pH calculation. So pH is the negative logarithm of your hydronium ion concentration. So that's negative log of 5 times 10 to the negative 3. And if you work out the pH, that will give you 2.30. Okay, and you can see clearly that it's a very low pH, which corresponds to what you have expected, because you're working with a very strong acid. So the pH should be very low because there's a lot of hydronium ions in your solution, because of the fact that you have a strong acid and therefore complete ionization with a high concentration of hydrogen ions. Okay, so let's go to our last example for pH calculations. So they're asking you to prepare a aluminium hydroxide solution. Okay, and they're asking you to prepare it with a pH of 12. So the question is, how much grams, so what is the mass of the salt that you have to dissolve in water to prepare a solution with a total volume of 2 liters? So first of all, let's write down what we have. So we want the solution to have a pH of 12, right? We want to figure out what the mass should be, and we know that the volume is 2 cubed decimeters. Okay, so first things first, always write down a balanced reaction equation. So if you don't know how to write the formula for aluminium hydroxide, you need to quickly grab your periodic table. So aluminium is in group 3 in your periodic table, so it will have a charge of +3. Okay, it means it has 3 valence electrons or electrons in its outer shell. Then hydroxide is just OH minus. So when we write down our formula, it becomes AlOH3. Okay, so that's the aluminium hydroxide. Now to write down the balanced reaction equation, aluminium hydroxide, okay, is going to ionize into aluminium ions and into hydroxide ions. So now once again, is this reaction balanced? Let's have a look. I've got 1 aluminium atom here, 1 aluminium atom there. Then I have 3 oxygens and 3 hydrogens. On this side I only have 1 of each, so I'm just going to put a 3 there to make sure that my reaction equation is balanced. So if we look at the molar ratios, it's 1 to 1 to 3. So where do we start? We know, because we have hydroxides in my reaction equation, that we are going to work with the ionization constant of water to calculate the hydronium ion concentration. So we're going to work with this equation to work out the concentration of your hydronium ion. And then from there on, you can calculate the hydroxide ion concentration. Okay, because in this case, they actually give you a hint as to what this is. And what they tell you is that the pH is 12. So in other words, I can work out what my hydroxide ion concentration is. So remember the formula to work out the hydronium ion concentration is 10 to the negative pH. So that would be 10 to the negative 12, because they told you the pH is 12. So your hydronium ion concentration is just 1 times 10 to the negative 12. Okay, and now you can work out your hydroxide ion concentration. Okay, the reason why while we're following this route is you always want to start off with the information that they give you and then work your way backwards to what you're actually doing. Okay, remember, we want to calculate how much grams of this should I dissolve. So I'm working my way back all the way from my hydroxide ion concentration to my aluminium hydroxide. Okay, so working this out will give you a concentration of 0.01 moles per cubed decimeter. So now I have the concentration of my hydroxide ions. Okay, but can I compare the concentration of my hydroxide ions to get the concentration of this? Okay, and the answer is no, because this is a solid. Okay, it doesn't have a concentration. Okay, it's only going to have a concentration if it's dissolved in water. So we are going to have to compare the molar ratios, we are going to have to work out the moles. So now that you have the concentration, we are going to have to work out the moles of hydroxide. So the moles is the mass divided by the molar mass. Okay, this is the moles. Okay, we are not going to use this equation, okay, because we don't have the mass of this. We can get the molar mass, but we don't have the mass. So we're not going to work with this equation. Instead, we are going to work with the concentration of OH minus is the moles divided by the volume. Okay, you want to work out the moles, you have the volume, and you also have the concentration. So this is 0.01. The moles is what you want to calculate, and the volume is 2 cubed decimeters. So if you work out the moles, you will find that your answer is 0.02 moles. Okay, so now you have the moles of your hydroxide ions, and now straight from that information you can now compare the moles. Okay, we always compare moles, and from that you can then work out the mass of your aluminium hydroxide. So let's quickly do that. I'm just gonna scroll down, okay, so that I have enough space. So aluminium hydroxide to OH minus. Okay, the molar ratio was 1 to 3, as I showed you in my balanced reaction equation. So we know that the moles here is 0.02 moles. Okay, so how are we going to get the moles of the aluminium hydroxide? So you're going to take this, times it by 1, and divide it by 3. Okay, or you can just say 0.02 times it by 1 over 3. Okay, and if you do that, you get an answer of 6.67 times 10 to the negative 3 mole. So now you have the moles of your aluminium hydroxide. And if you have the moles, you can go and calculate your mass. Okay, by using this equation, mole equals mass over molar mass. We want to now calculate the mass. We have the moles, and the molar mass you can get from the periodic table. So if I rearrange this equation, the mass of your aluminium hydroxide is the moles times the molar mass. Okay, so the molar mass taken from the periodic table, 26.98 for aluminium, plus these 3 oxygen atoms, plus there is 3 hydrogen atoms. So if you work out the mass, you get 0.52 grams. Okay, so I've showed you just now that from the given information, you can calculate the mass required that you need to dissolve in 2 liters of water to get a pH of 12. Okay, so I hope that was useful. It's quite a lot to take in. Stay tuned for the next videos where we will be looking at acid-base reaction equations, predicting what will form.